Okay, today we're going to do 4-4, modeling with proportions. Uh, these are just the goals. You'll be able to solve proportions and solve word problems using proportions. So let's get some vocabulary. A ratio compares quantities by division, and a proportion is a statement that says two ratios are equal. So anytime you have a fraction equals a fraction, you can do this. So how do we solve a proportion? Well, we use the cross products principle, which is the same as cross multiplying. We have A times D equals B times C. And that's all you do. You set them equal and then you solve for your missing variable. So if three of the numbers in a proportion are known, the value of the missing quantity can be found using the cross products principle. So let's do some examples. Solve each proportion and check. So we have our cross products. We have 10 times 3 equals 2 times x. So we have 30 equals 2x. We need to get rid of that 2, so we divide both sides by 2. We get x equals 15. Then that's our answer, which makes sense because 10 over 15, if you divide both of them by 5, you get 2/3. Okay? We can also do the cross products principle or cross multiplying when the bottom of your fraction doesn't look quite so pretty and you have more than one. So we have 20 times x equals 30 times x minus 10, or x minus 10 times 30. Then we distribute, and we get 20x equals 30x minus 300. Okay, it's a multi-step equation. We're going to need to subtract 30x from both sides. And we get negative 10x equals negative 300. Then we're going to divide both sides by negative 10. And we get x equals 30. So 20 over 30 minus 10. 30 minus 10 is 20. So 20 over 20 equals 30 over 30. We know that's correct. Okay, let's talk about solving problems using proportions. First thing we want to do is read the problem and represent any unknown quantity by x, or really any other variable. Set up a proportion that models the problem's conditions. List the given ratio on one side and the ratio with the unknown quantity on the other side. Each respective quantity should occupy the corresponding position on each side of the proportion. What this means here is that whatever you have on the top of one ratio has to be on the top of the other ratio. And we'll do a sample problem in a minute, and I'll show you what I meant. Okay, then we drop the units and apply the cross products principle, and we solve for x and answer the question. So let's do one. So here's our example. The property tax on a house with an assessed value of $480,000 is $5,760. Determine the property tax on a house with an assessed value of $600,000, assuming the same rate. So what do we have here? We have an assessed value of $480,000. So that's our assessed value. The property tax is $5,760. Then we have to determine the property tax, which means our property taxes are unknown on a house with an assessed value of $600,000. Okay, so we're going to let X be the tax on the $600,000 house, and we're going to set up the proportion comparing taxes to assessed value. So this is what I mean by paying attention to the values for the top and bottom of the fraction, or the ratio. So the property tax, we're going to put the tax on the top of our proportion and the assessed value on the bottom. So we have 5,760 is tax and assessed value is 480,000. So we have to set up the second proportion so that we have tax on the top and assessed value on the bottom. So the assessed value is $600,000. And we don't know what the property tax on that amount is. Okay? So now we're going to drop the units, so we're not going to pay attention to the dollars anymore, and apply the cross products principle. So we're going to do 600,000 times 5760 and 480,000 times x. And now we're going to solve for x. Oh, nope. So we're going to multiply first. So we get 480,000 x equals 3,456,000,000. Whew. Then we're going to divide by the 480,000 to get x by itself. And we get x equals $7,200. Okay? Great. That's it for today.